A very warm good afternoon to Honorable Speaker and member of AWS, esteemed faculty members of UPES, and all attendees. I would like to extend a warm welcome to all of you in the third webinar of the AWS Learning Series powered by AWS Educate in collaboration with UPES Cloud Security Alliance and Department of Virtualization School of Computer Science, UPES. The topic for today's webinar is AWS serverless architectures. Before introducing our esteemed guest speaker, I would like to introduce our chapter CSA. It is the only student chapter of UPES which is cloud specific and is collaborated with Cloud Security Alliance Uttarakhand branch. Now let me introduce our guest speaker, Mr. Neeraj Sharma. Mr. Neeraj Sharma is a technical training specialist at Amazon Internet Services Private Limited. He is an IT professional with 14 years of IT experience and with more than a decade of experience in executing projects and software delivery lifestyle. His expertise in architecting applications on cloud and DevOps. He worked as an associate engineer and associate system engineer at IBM India Private Limited. He was also working as a senior consultant in Oracle India Private Limited and as an application develop associate manager in Accenture Solutions Private Limited. He is PMP certified, PMI USA, Kubernetes certified. His other certifications include AWS Solutions Architect Professional, AWS DevOps Professional, AWS Security Specialty, AWS DevOps Specialty, AWS Alexa Builder Specialty, AWS Machine Learning Specialty, AWS Advanced Networking Specialty, AWS Solutions Architect Associate, AWS Developer Associate, AWS System Operations Associate, AWS Cloud Practitioner. He is also certified in Oracle BRM, Telecom Management, Microsoft Project Plan, IBM, AIX, DB2, Azure. His hobbies include running, music, and reading books. So, welcome Neeraj sir. Over to you.
Thank you, Vitesh, for the introduction. I hope you people can hear me, and now you should be able to see my screen as well. Just give me a second. Yeah, can you please confirm from your end as well that you can see my screen?
Yes, sir. It is clearly visible.
Okay, great. Great. So welcome all to this session on getting started with serverless, right? So what we will be covering in next 40 to 45 minutes, let me give you a brief about that. So we'll be covering the fundamentals of serverless computing on AWS, where I will be talking about a few key concepts around lambdas, a few things on API gateway, step functions, and some of our services, which revolves around serverless framework. Now, next, we will be discussing some of the architectures and use cases. And what I am planning is to showcase some of the live demos. I know live demos are a little risky, but I will try my best to showcase some of the demos around the services I'm going to discuss. Then we will open the floor for Q&A, and post that there might be some quiz which you may be attending internally, right? So that is the agenda on the plate, what we are going to cover in this 40 to 45 minutes of session. So I will start with the introduction to serverless computing, right? So when we say serverless, we have to first understand the context, how it all evolved, right? So we started with the on-premises servers, the physical virtual physical machines, and then we were at times not utilizing them fully. Moreover, there are compatibility issues with the applications running on physical servers. If I want to run an application, maybe in an operating system which is different from my host operating system, it's not easy, or it is not possible at that point in time. So there come the evolution, and we move to virtual machines, right? So virtual machines is where you run a hypervisor layer over the top of a host physical server, and then you run your virtual machine over the top of it. The role of hypervisor is to simulate to your virtual machines that they have their own bit of hardware, which is we call as virtualized hardware. Now, it was all good, but then some folks thought, like some genius minds thought, that it's still far from the ideal solution. So what they did is they started looking at kind of packaging the things a little better. They argued, why to run an entire guest operating system over a host operating system? Why can't we simply package all the files, whatever the libraries, the binaries, the dependencies together in the form of a template, and we can run that template on any laptop, any virtual machine, any physical server. So that is where containers comes into picture, right? So containers was born. So that was the second evolution. And after some time, with the advent of cloud technology especially, people started to think, what's next? And here comes the serverless. So serverless is, when we say serverless, it simply means that from a customer perspective, we are no more managing the infrastructure, right? So we are not managing the infrastructure provisioning. The advantage of serverless is manifold. One of the key ones being, you're not worried about the scaling part of your infrastructure. You're not worried about the high availability of the solution. You're not worried about the security of the infrastructure. So it is all being taken care by the cloud vendor. Now, if I just want to give you an idea, that in an on-prem world, basically what I am doing, I will be creating this virtual machine. I will be provisioning that machine. I will be patching it up. I will be putting the security patches, the necessary OS level patches. Then I'm installing the runtime. I'm installing my application, I'm deploying my application, and then finally I'm also monitoring the infrastructure as well as my application, right? So a whole lot of responsibilities to me as a developer, right? Why can't I just focus on building my application and monitor my application, right? That is what serverless provides to you, that you can just focus on the core expertise which you bring to the table, which is developing applications. Now, another good part is that you pay for the number of requests which this serverless framework executes. That's another beauty of it. If I compare it with virtual machines, if uh, I'm not having the request maybe during the night or maybe early morning, if the load is not heavy on the server, I still may be running those 50s or hundreds of virtual machines, right? Unnecessarily, and I'm paying for that. With serverless is a true pay as you go pricing, where you are just paying for whenever there is execution of the same, right? And as I mentioned, the high availability and the security is taken care by the cloud vendor. So this is our spectrum of some of the services which we offer. I have already talked about the virtual machines. So virtual machines are not eliminated entirely with serverless. They have their own use cases. Uh, you can install your applications over virtual machines if there is some kind of control or regulatory reasons you want to go for it, or in other cases you can go with our managed offerings, right? So some of our managed offerings you can see here on in the middle of the slide, which is ECS, EKS, EMR, Elasticsearch, RDS, Redshift, Elastic Cache. And towards the serverless, we have this Lambdas, Fargate, DynamoDB, S3, API Gateway, Step Functions, and things like that. So what we will be discussing as part of this session, I will be focusing more towards the lambdas, API gateways, and the step functions. So let's start with the serverless model itself, right? So serverless, basically it's an event driven model. Whatever functions you write, we also call them as function as a service model, where you just upload your code to the Lambda function, and Lambda function does the rest for you, right? So you can bring whatever language runtime you are currently working in. You don't have to change your language runtimes. uh, Most of the popular runtimes are supported natively, uh, and apart from that, if you want to bring a custom runtime onto the platform, even that is also supported. It supports various integration points with other services. Now, another aspect when I'm developing applications with lambdas is that I have most of the time plugins available with my popular IDs, like the IntelliJ or PyCharm or the Visual Studio. So there are these toolkits which developers love, and there are these IDs do support the lambdas deployment as a plugin which is available there. And I have already talked about that the major runtimes are supported, and it is also kind of compatible with most of the assurance programs like PCI, HIPAA, ISO. So lambdas are great for running my microservices architectures. As we know, we have moved from monolithic world towards the microservices world because of the advantages with microservices provides. So lambdas basically have a 15-minute execution time at most. So they are built for basically your microservices architectures. You have the automatic load balancing for high availability for lambdas. The more number of requests come to your lambda functions, the more is the number of executions spawned by the AWS. And then it supports some of the popular scenarios like fan out architecture, and it nicely integrates with the Kinesis, the DynamoDB streams, and the SQS as well. So a lot of services have the trigger points for lambdas, and I'm going to talk about some of the event sources that can trigger your lambda function. Now some of you may be asking, okay, this is good, what this lambda is, but can we check maybe from a console perspective, maybe just doing a short demo? So just if you can wait for a minute or so, I will just move to my console, management console, and show a quick demo of it, how a basic lambda function looks like. So these are the event sources on your screen. We have the S3, DynamoDB, the Kinesis, Cognito. So these are the data stores. From management tools also, we have the trigger points available for lambdas. And we can trigger our lambda functions from API gateways, step functions, even from Alexa. Yes. So when you invoke a skill from your Alexa device, under the hood, you are using a lambda function, right? So the business functionality is being taken care by Lambda. SQS, SNS, and SES, these are the event messaging services, which also have these integration points with Lambdas, right? So this is the basic Lambda function code. And what I'm going to do is I'm going to take you to the console and try to create a quick Lambda function and show it and try to explain some of the attributes from the console. So just moving my screen to the console. So this is my management console, and I'm going to create a simple Lambda function. So I believe simplicity is what brings power to the table. So I will just create a simple Lambda function so that everybody can understand how easy it is to create a simple Lambda function. So I'm just going for this service called Lambda. And what I'm going to do is I'm going to create a function. So there are multiple options available. I can author from scratch, or I can use a blueprint, or maybe from a serverless app repository. So these are some of the pre-built things which are available for me, which I can reuse. But for this demo, I will be authoring the Lambda from scratch. So what I'm going to create a function is that I'm going to give it a name called base Lambda. And now I'm going to choose the runtime. As I mentioned here, the runtime is being managed by AWS. So you can see there are
Excuse me, sir.
Yep.
So the console is not visible.
Okay. Just give me a sec. Is it visible now?
Yes, now it is.
Okay, really sorry.
No
When I
problem,
moved
sir.
to the console, I think it was missed. Sorry for that. So I was talking about the create function. You can author from scratch, or you can use a blueprint, or maybe a serverless app repository. So what I'm going to do is I'm going to create this function called base lambda. And I'm going to choose the runtime. As I mentioned, these runtimes are supported or managed by AWS. So you can see the various things or the various runtime versions available. What I'm going to do is I'm going to use a simple Python 3.6 runtime. And now I'm going to give permissions to this Lambda function. Now, Lambdas will be talking to some of the other AWS services. So what it needs some kind of privileges, right? So these privileges are in the form of a role. So when you create a new role for this basic lambda permissions, it gives the access to lambda so that it can talk to the CloudWatch service. So what I'm going to do is I'm going to create a new role for this basic lambda permission, or I can use an existing role as well. But for this demo, let me create a new role. So I'm just going to say create. And it is creating the skeleton of the Lambda function through this management console. So it is now created. As you can see, there is Amazon resource name, which is a unique identifier for any object in AWS. So you can see it here. There's this ARN which is available now. And what I'm going to do, there's an inline editor. So I'm just going to some of the code which I have pre-written. Is the basic Lambda function code. I'm just going to take it and paste it in the inline editor. So there are various options available. Either you can, if the code file is big, you can zip it and upload the zip file here, or you can put it in S3 and then upload the file from S3, right? So what this code is all about, let's quickly see a bit about it. So you can see it that this is a Lambda handler taking two parameters. One is event, another one is context. And what it is doing, it is just taking the first name from the event and the last name from the event. So event is basically the payload which is being passed to the lambda function, and it is just taking these two inputs from this event payload and appending a hello in front of it, right? So it is whatever I'm going to pass the first name and last name is, it is just going to say hello first name last name. So this is the message I'm going to see once I execute this lambda function. And then the various bits like environmental variables, tags, some of the basic settings like you can specify the memory for these lambda functions. You can edit it from here. It goes all the way from 128 MB to 3 GB in the 64 MB increments. Timeout, so by default it is 3 seconds. As I mentioned, the max is 15 minutes. And then if you want to configure the VPC thing, then you can associate this Lambda function with the VPC as well. Now the file system part is also supported. EFS, provision concurrency is a new feature. So these are all the things which are kind of a little advanced. So I'm not going into all these details because I've just created a simple Lambda function and I'm going to deploy it. So it says deployment package successfully saved. Now I'm going to execute it. So I'm just going to configure a test event. And here are the templates which are provided by AWS. So I'm just going with a hello world template. There are multiple templates which are pre-created by AWS, and I'm just going to provide the payload here which Lambda is expecting. So just giving the first name and last name. So just providing some details here and giving it an event name, dummy test. I'm just going to say create. And now I'm going to do a execution of it. So I'm just going to say test. So I can see that I got a message. Hello, first name, last name, right? Whatever payload I have provided to this Lambda function. Now, if I am interested, I can even go to the CloudWatch logs and see how these logs print the various start time, end time. And maybe if you're interested, you can even use some kind of a logging libraries in Lambda functions, which can help you in the troubleshooting or the debugging aspect of your code. So this is just a basic example which I have tried to showcase to you people. I will also try to explain some of the complex architectures, some of the useful ones towards the end of the session. So going back to the slide deck. Okay, so that is a bit about these Lambda functions. Now, just to specify some of the properties or some of the nice bits about Lambdas, what you need when you want some other service to act as a trigger for a Lambda function. So basically, you will be creating a resource-based policy in that case. So what I have explained is the execution role while creating the Lambda function, which specifies Lambda can talk to which other service. But there is a second part of the equation, who can talk to your Lambda function, right? So just give me a second, sorry. Yeah, so there are two parts of the equation. One is who can talk to your Lambda function, and once the Lambda is executing, what are the services it can talk to, right? So that is defined by execution role and resource policies. So that is a bit about Lambdas, just in a overview level. Now I will move to another nice service which is provided by AWS in terms of managing my backend APIs. Now I have created this Lambda function as an API, as a backend API. Now I want to expose it to my customers, how I'm going to do it. So the solution provided by AWS is known as API Gateway. It's a fully managed service from AWS, which acts as a front door for your backend APIs. The good part is uh, it helps your backend APIs to be prevented from being throttled, right? Uh, it can help you with the authentication and authorization at the API gateway layer itself. And the good part is that whoever is consuming your APIs, you can keep a track of it, that who has consumed how much of your APIs. And if they are going over a threshold, you can throttle those requests. You can make money out of your APIs by using the something known as API keys, right? So this is like a front door for whatever I have created. I want to secure, I want to authenticate, I want to maybe authorize the request to my APIs. On all those cases, this is the perfect solution. So let's see one architecture, how it all looks like with API gateway. Now I have my clients towards the left hand side. I can see my mobile applications, websites, and other services going through internet to the CloudFront distribution, and I invoke the API gateway. Now, API gateway, once it gets the request, it can either execute the API which I have created in Lambdas or maybe on EC2 instances, or it can even invoke the publicly accessible endpoints or other AWS services. API gateway have a caching layer, so it supports caching. All the monitoring is done through CloudWatch, supports something known as IAM, Identity and Access Management, which is our authentication and authorization service, and step functions. So step functions is something I will be talking in a little later. So just this is a architecture. Let me try to show you from the console perspective how it all looks like. Right. So I'm again going back to the console, and I hope this time it should be visible. So I'm just moving to API gateway. So suppose we have already created one API when I created the Lambda function, a basic hello world API. So I'm just checking, is my screen visible? The
Not
API
yet, sir.
gateway, not yet. I think there is some latency. Sorry for that. Let me try to do it once more.
Yeah, now it is.
Okay, thank you. Yeah, so what I'm going to do is I'm going to create some kind of API gateway layer for my backend API, which I created in the first demo, the Lambda function, right? So what I'm going to do is I will just say create API. There are multiple APIs supported, the HTTP, WebSocket, REST APIs, the private APIs where you can access the API gateway from within a VPC, right? So the APIs that are only accessible from within a VPC. So what I'm going to do is I will just go and build a simple REST API. Now, just assume that I have written something very fancy, though it is not, of hello world Lambda function. That was my API, the base Lambda function. So let me call this API as base API, and it will trigger my Lambda function, right? So there are multiple endpoints, regional, edge optimized, and private. So I'm just going with the regional. If most of your requests originate from one region, you can go with the regional endpoint. So I'm just going to say create API. And the next part is I'm going to create the wrapper, which is going to point to my Lambda function. So I'm just going to say create the resource, and I'm going to give it a name called demo. So what is a resource? Resource is nothing but a container for holding your methods. And what are methods? If you have worked with APIs, you might be aware of HTTP verbs. In case of REST APIs, are the methods. So for example, you can see methods like any, delete, get, add, poach, patch, post, put, all these things. So I'm just going to say get, and I will just initiate mapping it to my Lambda function. So if you can recall that I have created a Lambda function in my first demo. So I'm just going to use the same, the base Lambda, right? So this is the integration I'm doing with API gateway. I'm going to say save. And now it is saying that you're about to give API gateway permissions to invoke your Lambda function. So I say, yes, I'm okay with that. The moment I say okay, it opens up a new tab which kind of showcase the method request, integration request, integration response, and method response section. So basically what I'm going to do is that the Lambda function or the API which I created in demo 1, I'm going to use the same. I'm going to first validate the request, right? So what I'm saying is that if the end user sends a request with the first name and last name, it should be honored. If they miss any part of the request, then maybe they miss the first name or the last name, it should throw an error, right? So what I'm going to do, I'm going to say validate the query strings, parameters, and headers. And now I'm going to provide the query strings. So if you can recall, I use the payload with first name. I'm going to make it required, and last name. Yep. So I have done the validation. If any of the request does not satisfies the first name and the last name parameters, it is going to fail. Now I'm going to the integration request, and suppose I want to map the input request format into the format which Lambda expects. Then I can create something known as a mapping template. So what I'm going to do is I'm going to create this mapping template, and I'm going to say like application JSON template, and I have pre-created one template which I'm going to use now. So I have this template handy with me. I'm just going to use it. So what this template is doing, this template is just taking the input parameter first name and the last name and mapping it to the first name and the last name keys, which is being passed in the form of a JSON structure to my Lambda function. So that is it. I'm going to save it. Once I have done the validation in the transformation part, so this is another power of API gateway, that you can do the validation at the API gateway layer and the transformation as well at the API gateway layer. Now I'm going to test it. That's the next phase. Now I'm done. I have created the resource, I have created the method, I have mapped it to the Lambda function, and I have done the validation and the mapping part. Now I'm going to test it. Let me first provide, so I have used two query strings. One is first name, let me call it as John, and last name as Smith. And I'm going to test it. So you can see I got a message, hello John Smith, right? So it means my test is successful. The next part is to deploy this wrapper, the API. So I'm going to deploy this API, and I can create multiple environments here. So I'm going to create a stage called test, or let's call it prod. Assume this is the final version. I'm just going to deploy it to the prod. And the moment I deploy it to one of the environments, I get the invoke URL. So I'm just going to take it, and these are the various resources. So I'm just going to paste it in a new tab, and everything is ready. I just need to apply my resource and the query string. So query string, let me give as ABC, and last name is XYZ. Let me try to hit it on my browser. Sorry. I hope you can see the response on the screen. Hello ABC XYZ, right? So I have provided the query strings as ABC and XYZ. Now let me just remove the last name and try to hit it. So this is the validation failure. So last name, it fails at the validation layer, right? So you have seen that I have done the mapping, I have done the validation, the transformation, and I have used my backend API, which I created in demo one in the API gateway layer to create this wrapper. The good part is all my APIs are protected with the API gateway. The backend APIs are being can be authenticated and authorized with the API gateway layer. So all the nice bits which I need to kind of interact with my APIs is provided by this API gateway. Now I'm just trying to share the screen once more. If it is not visible, I hope my screen is visible. I'm on the step functions page now. So now I will be discussing a bit about step functions. So we have briefly covered about two key services in the serverless architectures thing. One is the Lambda functions, a bit about Lambda functions, and a few things about the API gateway. Now, what is this step function? Why I need it? Basically, in any architecture, you need a workflow. You need an orchestration engine. So this orchestration engine is the step function. So what I mean by orchestration engine, I mean that suppose you have created hundreds of Lambda functions and you need some kind of a coordination logic, which lambdas should get triggered first and which lambdas should get maybe if one of the lambdas fail, what is the response I need to take? Or one of the lambdas maybe I want to execute in parallel, or maybe if there is an exception with one of the lambda functions, what I do need to do next, right? So these are some of the key decisions I need to take at certain points in time. So here comes this service from AWS known as step functions. Those of you who might have heard this term called BPM, business process management, or business process monitoring. So this is more or less a BPM stuff from AWS, where you can create complex workflows with zero administration. The good part is you are not managing any servers, and it's all managed by AWS. It also gives a visual graph, a visual workflow, which you can see from the management console. And it nicely fits with my API gateway, with my Lambda functions and other serverless services. So you can see here that I'm starting with this first step, the first state. I move to a choice state, and if it matches, if one of the values being passed from the upstream matches maybe some threshold, it goes to this branch, or if it does not matches, or it matches something else, it may go to this branch, or maybe a default branch, right? So this can be the workflow which can be easily implemented in few minutes on the step functions. So before moving on to the next couple of services, what I'm going to do is let me quickly showcase the last demo for this session, which is on step functions. Now, I will be mimicking the same thing which is there on your screen. What I'm going to do is I'm going to provide a value to my step function, which is maybe anything like between 0 to 30. If the choice state makes a decision, if it is between 0 to 20, it should go to this state. If it is between 20 to 30, it should go to this state, else it go to this state, right? Nothing fancy, but just to kind of cement the concept. Let's try to see this quick demo on step functions, and then I will discuss a couple of architectures. So I'm just on to my management console again, and let me see if you can see the screen. Share it once more. Okay, so what I'm going to do is I'm going to step functions in the management console. And I'm going to create a state machine. So I will be mimicking the same stuff which I've shown on the slide. So there are two kind of state machines, standard and express. I'm going with the standard one. And then I have pre-created two Lambda functions before the session. So I'm going to use the two Lambda functions. So I have this first Lambda function, which is there with this ARN, and the second Lambda function with this ARN. So I'm just going to take this code. Step functions are written in a language known as ASL, Amazon State Language. So the moment I paste the code for the step functions, you can see that there is a nice flowchart kind of thing which has appeared on the screen, right? So what I'm going to do is I am just going to quickly explain what we are doing here. So we are starting with the start state. We are just by putting the payload to the next state, the choice state, whatever value we have received from upstream application, and then just checking the value is between a certain range. And I'm going to go to this particular place, the next state. If the value is between some other threshold ranges, then I'm going to go to a different state, otherwise to a default state. So this is what the three branches of my step functions. So I'm just going to next, and I'm going to give it a name. I'm going to use a role, an existing role. So this role is basically a means of my step function to interact with my lambdas. Logging, it is at the moment it is off, but I can enable it if I want to see the execution history in CloudWatch logs. I can enable something known as X-ray tracing as well, which is a means of basically troubleshooting or debugging my applications, especially the distributed architectures. But in this demo, I'm not going with the other options, all the other things I've kept as default. And I'm just going to create the state machine. So the state machine is created. I'm going to start the execution. Now, what I'm going to do is I'm going to put this value for this thing, maybe 25. Let's try with 25. I can give a proper execution name, but just for the demo, it's fine. I'm going to say start execution. So I can see that it has moved to this particular branch, right? So it has taken the value and it has evaluated that value here and moved to this branch. The good point is that with the step functions, you can run these workflows up to 1 year in time, right? So up to 1 year, these workflows can run, and it's not just about Lambda functions. You can even mix and match other services with these step functions. So going back to the slide deck, this was a kind of a small demo on the step function. I hope you might have got the idea what I've tried to explain. And now I'll just quickly explain a couple of architectures, just in very brief, and then we'll move to two other services. So basically, if I'm using a step function, what kind of architectures can be supported, right? So maybe think of on the lines that I put something into a S3 bucket, a Lambda gets triggered. This Lambda is going to start my step function, and this step function can trigger further Lambda functions, right? Maybe I have uploaded an image into an S3 bucket, and then Lambda triggers which start the step function, which further starts another few other Lambda functions, maybe in parallel. One of the Lambda functions creates a thumbnail of the image. Maybe another Lambda function creates a desktop version of that image, maybe other desktop resolution, or maybe a mobile resolution, right? And then all these Lambda functions provide the details back to the step function, and the step function takes these details and put it into the maybe a DynamoDB table. So that can be one architecture which is pretty popular with image processing scenarios with the step functions. Right. So that was something which I just want to quickly tell. One more architecture with lambdas I just want to share. So,
So sorry to interrupt you. Your
it's okay.
slides are not visible.
Okay, sorry about this. I'm facing a little difficulty in kind of moving across slides and moving across the screen. Sorry for that. I hope my screen is now visible. I am on the MS Paint screen.
Yes, sir, it is visible.
Okay, thank you. So I'm just going to explain quickly once again, and apologies for this. So what I tried to explain, let me show it once more. So I have some kind of a S3 bucket, and I have some kind of a Lambda function here. And again, apologies for my bad drawing. I will just try to showcase it from there. So this is my step function. And then I have multiple Lambda functions, right? And then one more Lambda function here. And this is my DynamoDB table. And let me now put the names to it quickly. So this is my S3 bucket. This is my Lambda. This is my step function. This is my processing Lambda 1. This is my processing Lambda 2. This is my processing Lambda 3. This is maybe the final Lambda, which is going to just publish the details, the publish Lambda. And this is DynamoDB. And this is my end user, or maybe a user application, right? So how the flow looks like that the user uploads through an app some image into S3. A Lambda gets triggered. This Lambda invokes the step function. The step function invokes the further Lambdas, which are the processing Lambdas, sorry. Okay. And finally, all these Lambdas publish the results back to step functions, and step function invoke another Lambda, which is the publishing Lambda, which put all the details in a DynamoDB table. And then the user app can retrieve the details from this DynamoDB table, right? So this can be the image processing scenario I talked about just a few minutes back. And if I just want to maybe explain one more scenario using lambdas. So basically, if this is a modern day architecture which a lot of customers are using. So this is suppose my S3, the simple storage service, and where all my static assets are present, the video files, the audio, the media, the static files like the HTML, the CSS, the JavaScript, whatever is there, I have placed it in S3. And this is my API gateway. And this are my backend APIs, maybe Lambda functions or HTTP endpoints or other services. So these are my backend APIs. And maybe this is my persistent storage. Can be S3, RDS, DynamoDB, whatever you have chosen. Now, what happens is in this kind of scenario, we at times we also use something known as Cognito, which is our authentication and authorization service for mobile or web applications. So this is Cognito. So what happens here is this is my end user or the application of the end user. So this user first, maybe you are not directly interacting with S3. You have something called CloudFront coming into picture, maybe even Route 53, which is our DNS service coming into picture, right? So this is CloudFront. This is the Route 53. Now the user request goes to maybe Route 53, resolves to the CloudFront URL, and then you get the link to the static website. So maybe you provide your details, you get a token from Cognito, which you provide to the API gateway, and then which based on the icons or the buttons you click on the website, you are further invoking these backend APIs, and maybe these backend APIs using some kind of persistent mechanism. If it's a microservice model, each of it, this is having their own persistent storage. So this can be another architecture, a modern day architecture, which customers are implementing and finding it useful. All the static part going through S3 and the dynamic part going through the API gateway. Just I'm showing the screen again. Let me see if I can share it. Yeah, I hope it is visible on your side. So security and identity. I am identity and access management to control the access to AWS resources. And Cognito, as I mentioned, it consists of two key elements. One is known as user pools, another one is known as identity pools. So user pools for managing your user directories. Maybe you don't want to manage the user sign up, sign in information on your side. You want to offload it to AWS. So in that case, you can use Cognito. So it is basically from an end user perspective, and this is from maybe your internal users perspective, if you want to control access to certain resources. So user pools is like the directory for your users where they sign up and sign in, and identity pools is basically where you provide the role based access. For example, when you get the token from Cognito, you can give it to identity pools and get the AWS temporary credentials, which are there with a role. So you can get those credentials, and once you have those credentials, you can access other AWS services. For logging and monitoring, we have this service called CloudWatch. There are multiple subsections within CloudWatch: CloudWatch logs, CloudWatch alarms, events, matrices. So a whole lot of stuff comes with CloudWatch. X-ray is what is the distributed tracing service we have in case you want to troubleshoot your microservices architectures. So it gives a nice graph where you can, known as service map, you can just debug your applications, the latency between these applications, the bottleneck between the applications using this service called X-ray. So various services on AWS like Lambdas, API gateways, Step Functions supports X-ray as well. So this is all I want to cover as part of this session. I'm open to any questions you may have on whatever we have discussed so far in the last 45 to 50 minutes. And sincerely apologies for just maybe at times my screen was not visible due to the swap I'm doing between different screens to showcase you some demos and architectures.
If you have any questions, you can write it in chat. So Yuvraj is having one question. He is asking about which language Lambda functions are created in.
So you can create Lambda functions in multiple languages. The most popular ones are supported. For example, Ruby, Node.js, Go, Python, Java, C Sharp, .NET. So all these languages are supported. In case you want that there is something which is not natively supported by Lambda functions, in those cases, you can even bring your own custom runtimes. So that facility is also there. So it's supported. Yeah, so whatever you want to create on Lambdas, that is supported.
Sir, also there is one question from Tahira. What is the difference between CloudWatch and AWS X-Ray?
Okay, great question. So CloudWatch is our monitoring service. Basically, it consists of several sub services, I should say. Like I mentioned, for logging, we have something known as CloudWatch logs. For matrices, we have something known as CloudWatch matrices. Based on those matrices, you can create alarms. And then various services also publish certain events known as to something known as CloudWatch events. This is basically our monitoring service in a nutshell. X-rays is primarily a service which is meant for debugging, performance tuning, and troubleshooting the distributed services, distributed architectures or microservices, which you have primarily created from Lambdas or maybe some of the applications running on EC2 instances. So these are two separate things. One is basically for monitoring. The another one is basically for troubleshooting your distributed architectures or microservices. Right? So it looks on the surface that they might both be doing the monitoring thing. It's not. Monitoring is a separate domain and tracing is a separate domain. So if maybe if you can go through something known as the logging, tracing, and the monitoring triangle, we called it as observability pillars, then you can get little more about what's the difference between monitoring and tracing. So it's not it's complementary, but again there's a slight difference between the two, and hence the services are different. I hope that answers.
Uh, So there's another question from one of the faculties in Department of Virtualization UPS. He wants to know that what are the kind of services which are available to AWS educator users?
uh, I'm not sure about it, to be honest. Maybe if we can take this offline.
Okay, fine, thank you. And Raghavendra Singh is asking that is Python preferable over other languages for creating Lambda function?
There is no such guidelines or recommendations. It all boils down to your use cases or what you are comfortable doing today in your on-premises world. So Python, it's a popular language. We know that it's like multi-purpose language. A lot of people are, or a lot of developers kind of move towards Python because it's easy to understand. But then there is no such I should say bar saying that this language is better than the other language when you're creating these Lambda functions.
Okay, so thank you. And there is one last question that how we can use load balancers.
Load balancers. So load balancer is a service which we provide in the form of like three flavors or three categories. The elastic load balancer, we call it a CLB, the application load balancer, and the network load balancer. Uh, so if you are interested in knowing more about these load balancers, maybe you can explore the documentation page where they clearly talks about what's the difference between each of these load balancers. Due to the brevity of time for this session, I may not be able to kind of give you in detail about how these load balancers function, because I need at least 10 minutes to explain the entire stuff. Yeah.
Okay, thank you so much, sir. I would like to extend a very hearty thanks from Department of Virtualization and UPES CSS student chapter for finding out time from your busy schedule and sharing the knowledge with us on AWS services. We look forward for such more interactions with you in future also.
Thank you
Thank you.
so much. Yeah, thank you
Thank you
so
so much,
much.
sir.
Thank you.
Thank you.
Thank you
I
all.
would like I would like to request the panelists, I would like to request the participants over here to stay tuned for the quiz session. Vitesh, are you there? It is over to you now.
Yes, ma'am.
Okay.
So thank you, Neeraj sir. Sir, can you please stop sharing your screen so that I can share? Thank you, sir. So I hope you all have enjoyed the session and learned a bit. So let's move to the quiz session. So is my screen visible to all?
Yeah, it is visible, Vitesh.
Okay, let me start the quiz and I will tell you the instructions. So kindly log into the www.kahoot.it. I will paste the link. Please log in with your original name so that if you win, we can send you a gift coupon. Please write the game pin as 2594423. Please log in fast. We will be starting in a couple of minutes.
I think, Vitesh, we should start.
Okay, ma'am, I will start. let's begin. Here is the first question. Which of the following services are not supported by AWS Lambda? So S3, CloudFront, Alexa, EC2. You need to match the color code. That is, you need to match the S3 for red, blue for CloudFront, yellow for Alexa, and green for EC2. So correct answer is EC2. Let's see the scoreboard. Tahira is on top. Let's move to the next question. This is a multi-select question. Please be careful. You need to select the two answers. Which of the following are handled by a Lambda by default? Red for auto scaling, blue for Lambda functions code, yellow for security patches, and green for triggers that activate the function. So the answers are auto scaling and security patches. Let's move to the next question. Here is the scoreboard. The scoreboard has changed. Rahul Sharma is on top. So here is the third question. Which language is not supported by AWS Lambda? So it is a single select answer. So red for C++, blue for Python, yellow for Java, and green for Node.js. So the correct answer is C++. 34 got it right. Here is the scoreboard. The scoreboard has changed. Pratusha is on top. So moving on to the next question. What are the advantages of auto scaling? It is red for better availability, blue for fault tolerance, yellow for better cost management, and green for all of the above. 39 got it right. Here is the scoreboard. Vidhu is on top. Let's move to the fifth question. Which of the following must be configured on an elastic load balancer to accept incoming traffic? So, options are red for port, blue for listener, yellow for instance, and green for network interface. So, the correct answer is listener. Let's see the scoreboard. It's 2594423 is on top. I for, said you please log in with your name. So let's move to the next question. Which service can call Lambda function asynchronously? It's red for Amazon DynamoDB, blue for Amazon CloudWatch events, yellow for Amazon API gateway, and green for Amazon simple email service. So the correct answer is Amazon API gateway. Let's look to the scoreboard. Devanshu Pathak is on top with 3696 points. Let's move to the last question, seventh question. It is a multi-select question. Please be careful. Which of the following are found in an IAM policy? Red for password, blue for service name, yellow for action, and green for region. It is a multi-select question. You need to select the two answers. So let's look at the podium. Who will be our top three? Yakshu is on top. Yakshu is at number three. Congratulations. Vedu is at number two, and Rahul Sharma is on number one. Congratulations to all top three winners. So I hope you have enjoyed the quiz and the session. So I, Vitesh Sethi, on the behalf of UPES CSS Student Chapter and Department of Virtualization, School of Computer Science UPES, would like to thank all the members and the speakers of AWS, esteemed faculty members of UPES, and all the attendees who have joined us for the AWS Learning Series. We would like to see you all in the we would like to see you all participating in the future events from UPES CSS Student Chapter. Thank you all.